During engine break-in, the piston rings and cylinder bores will wear into each other. Unlike an iron cylinder bore, which will wear as the piston rings seat, Nickel will not. In engines with nickel-plated cylinder bores, the surface finish preparation is critical, especially achieving a proper plateau hone. If the surface finishes or cylinder concentricity is not correct, the rings will take longer to seat, or will not seat at all. This is where light checking the rings comes into play, assuming your cylinders are properly honed. Once you have gapped the piston rings, you can use a precision ring gauge, but for more customers it will be sufficient to light check the rings. As the name describes, we are looking to see if the rings are light tight in the bores, meaning that you can't see any light passing by the face of the ring. Top rings are always OD lapped, so it is rare to see them not pass a light tight test, unless the ring is not correct for the bore size. If you have to remove a lot of material from the ring to correct the end gap, or the gap is already excessively large, that is usually a good indicator that you have the wrong ring, and that it may not pass the light test. The second ring is critical to light check, as it functions as the engine's second oil control. If the second ring does not test light really tight, engines will tend to use more oil and even smoke, so it is very important to check this. Oil control rings do not need to be light tested. However, their radial tension is something professional engine builders often will check. Light checking piston rings in your cylinders will ensure the best case scenario for engine break-in, and ensure proper ring seal, assuming you have properly cleaned and prepared your components for assembly. Just like light testing of the rings, measuring ring tension is something that is not checked very often. Specifically, we're going to be verifying the oil control ring tension by fitting each piston to each cylinder with just the oil control ring installed. Cylinders and rings must be thoroughly cleaned and lubricated. There are many different techniques to actually measure tension, but most feature using a fish, luggage, or trigger pull scale. Care must be taken to not measure the breakaway force, but rather the constant force that is being applied to push or pull the piston through the cylinder. Most modern sets include low-tension piston rings. These have an average radial tension of 8 pounds, compared to standard tension rings with 20 pounds of radial tension. For most customers, the supplied 2 and 2.8 mm oil controls will have the correct tension for use with nickel bores. Ideally, for nickel bores, we would like to see radial tension around 10 pounds, as we've documented that tension typically drops about 1 pound after break-in. Some applications may benefit from more or less tension, which can be achieved by swapping out rails and expanders to adjust radial tension. For experienced builders, modifying the oil rail expanders can affect tension as well.